Okay, so we're going to look at math commands. Now, to get LaTeX to realize that you want to do a math command, to have a math symbols, you need to somehow get it into something called a math mode. And there's different ways of doing it. I'm going to show the most basic math mode now, just to show you how to do commands. And then we'll do a few videos where I show you some different math commands. And then I'll show you some different videos to get math to display a little bit better, so everything we're doing now in this video and for the next few videos, I'm just going to show everything in line. Like, we're going to have stuff right here, and then there'll be math, and then more stuff, like just a line, then some math, and then keep going. But then in other videos coming up, we'll see how to do some math here, and then come down into a new line and have things centered horizontally and stuff like that. But for the first few videos, I just want to introduce you to just kind of the basics of writing math in LaTeX. So let's just begin. Let's say the Pythagorean theorem. I hope I spelled that right. I'm not good at spelling, but we'll do spell check. The Pythagorean theorem says that if a triangle has side lengths. Okay, so now the side lengths are gonna be A, B, and C, but I don't want to just have the letters A, B, C, because if I write that, look at it, had side lengths A, B, and C, I wanted to look like math letters. So for example, if I didn't worry about math at all, so I wanted to look like math letters. So to get into math mode, you do a $sign, and then LaTeX is automatically going to open another $sign, and everything you put within this $sign is going to be in math mode, and it's going to look like it's written. It's going to be written in a script. It's going to look like math. Okay, so I'm just gonna recompile this so you can see what it's going to look like over here. Okay, make this a little bit bigger. So now it's kind of in the typical math script that you're used to seeing math written in. Okay, so the Pythagorean theorem says if a triangle has side lengths A, B, and C, where C is the hypotenuse. I normally don't say hypotenuse that way. I had to say it that way to spell it correctly, but I still spelled it incorrectly. I'm bad at spelling. That was embarrassing. Okay, so if a triangle has side lengths A, B, and C, where C is the hypotenuse, then so now I'm going to do our first equation in math. Again, I'm going to do $sign, and I'm just going to now type what the equation is. It's A squared plus B squared equals C squared. So to do A squared, it's going to be A, then the caret squared plus B squared equals C squared. Okay, so this is to get a superscript, you do A squared, you do the caret like this, A squared plus B squared equals C squared. Now I'm going to compile it, and we'll see what we look like. Okay, A squared plus B squared equals C squared. Notice if we try to do this not in math mode, LaTeX is just going to literally write, A caret 2 plus B caret 2 equals C caret 2. So for example, A squared so notice it's actually not even letting me, so I'm going to do a backslash here. We'll learn more about this backslash later, but the point is when I compile it, it just has that's not right. Okay. Okay, to show what I'm trying to show you, if I just do A times A plus B times B equals C times C, C times C, and I compile C times C, and I compile this, then we have an equation. This is A times A plus B times B equals C times C. That's technically correct, but it doesn't look like math. When we see a mathematical equation written, we're expecting that it's going to be written in this script, and it's going to look different from the other writing that's around it, from the exposition that's around it. Okay, in upcoming videos, I'm going to show you some more symbols as well, and some more things to do.